Okay, so now we're back here. This is part 3 of these notes. And we're going to start off again with an activity. Geometry is very visual. So the more that you can do kind of hands-on stuff, the more that you can visualize what's happening, the easier it's going to be to kind of see relationships, to understand relationships. So what we're going to do here, it says use the compasses. I'm actually going to use straws to try to draw triangles of certain lengths. I want to make some triangles. And the question is, can I just pick any values that I want? All right, so the first one I'm going to try to do is 3, 4, 5. Can I make a triangle where the side lengths are 3, 4, and 5? Well, it just so happens that I do have 3 straws. This one is 3 centimeters, this one is 4, and this one is 5. The best way to do this is actually to take the longest one, and I'm just going to kind of put that at the bottom. And then here's the 4, here's the 3. Now notice that they don't match up yet, but can I manipulate these? And it looks like I can. They're kind of rolling around here. Alright, so something like that. So that looks like 3, 4, and 5. Yeah, that's going to give me a triangle. Okay? Now what about if I try 3, 4, and 7? Here's the 7 right here. So let me put that at the bottom. So here's 3, here's 4. Now right there, the 3 and the 4, they don't meet yet at that third point for a triangle. So I'm going to have to move it in like this. Something's happening though. Notice it as I close it up. They're not touching, they're not touching. The only time they touch is if the 3 and the 4 are collinear, if they form a line. Now, that would add up to 7, but the problem is that that's not a triangle. A triangle is not 2 straight lines. A triangle is 3 lines that meet each other, 3 segments that meet each other at 3 different points. So 3, 4, 7 is no good. So we can write 3, 4, 5. I'm going to put a little check mark. Yeah, that's a triangle. 3, 4, 7 is no good. That won't work. That's not a triangle. The 7 is just too long for the 3 and 4. It's too long. Now the last one is the 9. And actually, I got to be honest, this one is 10. I don't have a 9 centimeter straw, so I'll make that 10. Here's the 10, and then here's the 3 and the 4. And what you notice right away, 3 and 4 are too small. There's no way that they're ever going to meet. It doesn't matter how much I, rotate it. No, that's no good. That's not a triangle. So 3, 4, and 10 is a no. Alright, so what this does is it leads us to a very important idea, and this idea is called the triangle inequality theorem. And what it says is that the sum of any 2 sides in a triangle is always greater than the length of the third side. So if I take a triangle, and I'll call the sides A, B, C. Now notice the way that I'm labeling this, these are not the points. This is not vertex A, vertex B, vertex C. When I label the sides with a letter, I use a lowercase letter so that you don't accidentally mistake that for a point. Okay, so these are the sides. What the triangle inequality theorem tells us is that if you add A plus B, then that sum, okay, sum is where you add them, that's bigger than the third side. It has to be, if it's a triangle, that has to be true. If you add the B plus C, the sum of that has to be bigger than the third side, which is A. And if you add A plus C, that has to be bigger than the third side. It has to be greater than the third side, which is B. Okay, now here's a kind of a quick way to check this. Add the 2 smallest sides. And then you ask a question, is their sum greater than the third side? Is their sum greater than the third side? If it is, then yes means that it's a triangle. Okay, we'll say it's triangle. If their sum is not greater, so if it's equal or less than, then you have to say it's not a triangle. Okay? So for example, let's look at these in number 4 here. So 5, 2, and 4, could they be the lengths of a triangle? Now, when you do this, you have to add the smaller sides, the two smaller. So if I add 2 plus 4, the question is that bigger than 5? Now 6 is the sum, that's bigger than 5, so we say yes, it's a triangle. We could make a triangle with these lengths. Now how about 4, 5, and 9? If I add 4 plus 5, is that bigger than 9? And the answer to that is no. You get 9, which equals 9. Well, that would be the situation with the straws where the two smaller ones can't, the only way to match the bigger one is to make them collinear, which is not a triangle. So that is a no, that's not a triangle. Okay, and again, it would look, if I try to do that, that's the only way that I can get 4 plus 5 to be equal to 9, but that's not a triangle. Okay, so that's no good. You go ahead and do these 3. So go ahead and pause it, do these, and then check back and see if I get the same thing that you do. All right, so 5 plus 8. You take the two smaller sides. Is that bigger than 10? 13 is bigger than 10, so that is yes, a triangle. 7 plus 7, this is isosceles. Is it bigger than 10? 14 is bigger than 10, so our answer is yes. That is a triangle. Now 8 plus 8, is that bigger than 17? Well, 8 plus 8 is 16. That's less than 17. Not a triangle. That's no good. It's impossible. You know, go ahead and try it. Take 2 straws. Take pieces of paper that are 8 centimeters. Okay, it's not going to work. All right, now the last type of question here that we'll look at, what are the restrictions on the third side of a triangle if 2 of the sides measure? Okay, restrictions is kind of like a boundary. So let's say we had a triangle here, and we'll say 2 of the sides are 4 and 6, and the third side is x. What could be possible values of x? Well, one thing we know, in this case, we're not sure if x is it the smallest side or is it the biggest side? Or is it the middle side? We're not sure. Let's say that x was the biggest side. So that would mean 4 plus 6 would have to be bigger than x. Okay? Now that's 10. 10 would have to be bigger than x. So that means x is less than 10. So x would have to be smaller than 10. It could be 9. It could be 9.9. It could be 9.99. But it cannot be 10 or 11 or 12. Now that's one restriction, but x also has a lower boundary. This is the upper boundary. There's going to be another boundary, because what if 6 was the longest side of the triangle? Then that means x plus 4 would have to be bigger than 6. If you add the 2 shorter sides, the sum has to be greater than the third side. So you could solve this and go minus 4, and what you get is x greater than 2. Okay, so what happens here is we get 2 restrictions. The way that we're going to write this is we'll say 2 less than x less than 10. X has to be between those 2 numbers. Now it could be 2.01. That would be okay. But 2 is no good. 1.5 is no good. 8 is okay. 7.26 is okay. Now there's actually kind of a shortcut for this. Notice that our 2 answers were 2 and 10. Well, if you look at 4 and 6, which were the 2 sides they gave us, if I subtract those, 6 minus 4, I get 2. And if I add those, 6 plus 4, I get 10. So you can actually do this as a shortcut. I'll show you with, let's say, 18 and 12. Okay, here's my third side, x. If I Add those up, I get the upper boundary, which is 30. If I subtract them, 18 minus 12, I get the lower boundary, which is 6, and x is between them. The way you read this, 6 is less than x is less than 30. Okay, so that's a less than symbol there. X is between the two values. Okay, and how about for the last one, 22 and 35? Do you really need to even have this picture that I'm drawing? No, not really. But I like to have it. Again, I'm trying to be visual. Okay, so if I subtract these, I get 13. If I add them, I get 57. The third side has to be between those. Now, I'm not saying I don't know the exact value of x. I don't know if it's 20. I don't know if it's 35. But I know it has to be between these two numbers. Not equal to them, between them. And that is the end of part 3.